keyboard not working. So it says it powers on but doesn't boot to login screen, and it says trackpad and keyboard not working. Okay. Let's see. Now, given the color of it, we know for sure that it's not going to be M1. So because the M1s do not have this color. So so once you see this color, you know that it's definitely not M1. And let's see what the model number is. The model number is 2992. 2992. So it's 2992. It says trackpad and keyboard not working. So it's a 14 inches, and we don't see it going on. I guess the battery is down. So let's try to. So because it's not an issue of no power, so I mean the fact that if they say keyboard and trackpad working means the device starts. So let's connect our charger. Interesting. Oh, it is actually on. Wait. But because trackpad and keyboard not working. Ah, interesting. Okay, so the one thing when it comes to trackpad and keyboard function, so the keyboard, it's by design the keyboard will communicate with the board via the trackpad. So if you have a problem with the trackpad, what's going to happen is the keyboard is not it's not going to work. Now there are two things. So especially with devices with haptic feedback, there are two things you want to understand. So when this gets power, when there is power on this, when the haptic engine gets power, you should have a feedback. That is going to be primary. So that will be, so before you even worry about if the trackpad itself is working, you want to check that, you want to see that the trackpad itself is getting power. So, but right now what we see is the trackpad itself doesn't get power. Then there's something else. Now, then with newer design, there's a bit of a change in terms of how the trackpad reacts. So with older design, when the device powers on, immediately the device goes into SO state, the trackpad becomes active. With newer design, what I started to see is the trackpad doesn't become active immediately. So it gets to, so while the device is booting, it only gets to a point before the trackpad activation picks up. So let's you booked the device in, correct? What year is it? 2023. Okay. So I'm not sure how, but the fact that this is now the device is completely booted, and obviously we don't have a trackpad feedback, so we're not going to worry about the keyboard for now, because the trackpad will work independent of the keyboard. Whether the keyboard is present or not, the trackpad will work. However, the keyboard would not work without the trackpad. So our assessment or our troubleshooting is going to be dependent on the trackpad. By the way, this was the same machine that they requested other machine to test the trackpad. So as they have also done so, they have, I believe they have also because they requested for a trackpad for this device, and then they did a test. So I suppose they have tested the trackpad with another one, and it still didn't work. So our focus is going to be the keyboard, the trackpad circuitry. So we're not going to worry about the keyboard. So okay, it's okay. Let's see what is it that we are dealing with. So you understand what I'm saying? So whenever you have issues that has to do with Apple, the design, it's that's how they that's how the architecture go for Apple devices, most of their devices. So the keyboard, the keyboard gets power through the trackpad. Okay, so let's see what's going on. Hopefully the device is not liquid damage. Hmm, looks pretty clean. Really clean actually. So the device is not liquid damage. Okay. So let's let's take a look at what is it that stands out. Okay. So the device is not liquid damage. So like I said, our focus is going to be solely for now squarely on the trackpad circuitry, unless along the line if something stands out. But for now, our focus is just going to be on the trackpad circuitry. So let's start by disconnecting the battery cable. It's disconnected. The trackpad cable. Need a T5 for that. T4, not a T5. And T. Okay, so it's first thing we're going to worry about is we want to see what is it that we have on. Let's see, what do we have on the trackpad connector itself? Do we have anything that looks okay? Let's see what the board view is. So I suppose the board number will be under the keyboard. So it's 820-28. Let's see. You know what this cable is, correct? What cable is it? This one. Cable, yeah, that's correct. So the board number is 2918 02918. Let's see if we have that. 02918. I don't think we do, but I think 02918. Let's see, 02918. If not, we'll have to use the 2021 02918 02. Nah, 02918. Let's try to search, but I highly doubt we do. 820-02918. No, it's 918. Yeah, 918. 918. Nah, nothing. Okay, let's use this one. Remember the one that we got for the M2? Not that one. Let's see, 02536. Let's check that one. No, not that one. That's M2 Air. Not you, not you, not you. Yeah, it's this one. 2655. Yeah, this guy here. 2655. 2779. Yeah, it's this guy here. We did use this guy. Okay, so we can use this. Although so first thing first, we want to look at the power for the trackpad. So let's look at how the trackpad is supposed to function. So first of all, we want to look at the pin 41 up until, so that is going to be the high voltage line for the trackpad. You see where it says 41, 42. So from 41, 41. You see this point here, that's going to be the high voltage line. So you should have 12.0 on that line. So it's going to be this side and that side. So first of all, let's see what is it that we have. Let's see, and obviously that will be when the device is in SO state. So let's see what voltage we have there. Mm, 0.0, that's present. And another thing is, you see the fan sometimes when your fan ramps up and then your fan is very loud, that will be because the trackpad, its cable is not present. So okay, let's see. So that is present. So what we want to do now is the other rail on the trackpad, we will not have access to them without having to take the board out. So let's take the board out quickly and then see what is present and what is missing. So we're going to start with a T2, so T4 screw. See, they changed the color. Remember, so this is supposed to be black, but now it's white on the M3. So those are some of the small details that you can quickly pick up, even without, say, for example, if you see an M3 that 2023 14 inches, but it's a space gray or silver. By seeing the type of screws inside, you can easily tell, oh, this is a 2023 14 inches, not the 2021. Let's quickly take the. Yes. That one there that has the black screws. Which one? That one? The one, yeah. The one that you're busy with, yeah. And so that should be true with the M1 and the M2. So what they actually did was, so you have that being white, but the main screw on the board still remains black. See, they already took the board out, they did their own assessment. So they probably couldn't figure out. But other than that, you see the screw types are still the same, just the colors that have changed. The type is still the same. And remember, this and that being of the same set is still being maintained, same. And obviously this on previous ones, that obviously that's a T6 and is the longest of them, and it stood out in terms of how we look. Okay, that's also going to be a T6. It's still a T4, T5, still a T5, so we're going to need a T6 for that. Then this also. So you see the screw heads, the beats are still the same. So now we're going to need a T6 for that. So let's get a T6. Yes, we were able to use a T5 for this on the previous ones, so we still can use. So it basically the same thing, just yeah. So let's get a T6. Exactly the same, and this would stand out. Whoever put this back, let me see. I will think they got it wrong. You see, so because you see that in terms of length, this is longer. So let's see. So whoever put it back, they probably didn't pay attention to that detail. So what was supposed to be here, let me grab that. Where did it drop into? Okay, yeah. So you see, they didn't pay attention to it. So remember, it should come in set. The one that's here is supposed to stand. It's supposed to be completely by itself. So this and this, these two here are supposed to be here and here. And then the one that the one that he put here was supposed to be the one that goes here. Because if you look at, if you see, this is the longest of them. But obviously the person just thought that, okay, they all T6, so just, yeah. Okay, So it's important. It's important to pay attention to the details. So you see, they still follow the same pattern, even though the colors have changed. And also, you see that that's something. You see the barcode. That's something on the 2023s. Not that's not something you find in 2022s. Do you have a barcode in 2022? Can quickly bring it. 2021, the M ones. So it's also something to take note of. You see, with the M1, there's no barcode on it. So that's also something to take note of when you see the USB-C charging port. You can easily tell, oh, this is an M3 charging port. See those small details. It uh, gives you a hedge ahead. Okay, let's be very careful around the Touch ID cable. Okay, board is out. Let's have a look at the other side of the board, see if anything stands out. And the board is clean. Oh, by the way, I should mention that if okay, let's hold on. Let's just hold on to that for now. Let's see if anything stands out. This is such a clean board. So, what could have happened here? Actually, I should mention it. If nothing, if we don't pick up anything on the board, then we have to put the device in DFU mode and revive it. Yeah, and it's also going to be interesting to see if the device will go into DFU mode. Remember, you need a combination of the keyboard to put the device into DFU mode. So yeah, it's also going to be interesting to see if that will be the case. Okay. Nothing stands out. Okay, so now let's check the voltages that are required. Yeah, let's check what's required. So the voltages should be we should have two set of signals and voltages required for this. We should have the bidirectional lines. Bidirectional lines usually they will require A to be present in order for B to be activated. Do you understand? So some of the voltage will be present even without the trackpad being present or signals. But then some will only become present only when the trackpad itself is connected. Remember the same scenario with the USB 5-volt line output not being present until you actually connect the USB device. Okay, so let's see what is it that right now we are going to be using a USB-C cable. Okay, so let's see. We confirm that this is present, so let's start from the beginning. So J, IPD, we're not going to worry about that. Let's check what we have on the I2C line. So let's see if that is present. And we can measure that on the other side of the board. Let's flip it. So on the other side of the board, we can measure that. What? we can measure that here. So that should be, yeah, C. So this and this is gonna be this guy and that's for your keyboard. And then just above it, you have this guys here, which are this ones. And if we move a little bit forward, both that. Okay, apparently that's not present on the board. This so there's supposed to be three resistors, the three spots there, but here we only have two, and it's not present. Okay, let's check anyway. See if we can get that voltage present. No, no. Okay. Let's move on. ITC, it's not about that. SPI trackpad, let's not worry about that for now. ITC keyboard, let's not worry about that for now. SPI trackpad, let's not worry about that for now. Let's first of all concentrate on the power. So IPD system wake, that it's not. So basically, that would be a signal that should be active or pulled up when your machine is sleeping and then you touch your trackpad, and then the machine goes to wake. So let's not worry about that for now. Not for now, not now. We want to really concentrate on the power. So SPI, IPD, touch, okay, not now. And that it's gonna be an interesting one, but we might not really worry about that for now. But let's just see if that is present. Okay, yeah, that should be present because that is on the other side of the resistor. We should have 3.3 volt, correct? So let's see, do we have that on the board? Yes, we do. So it's this guy here. This one here. Let's see. We're supposed to have 3.3 volt. Wait, no. Is the machine itself on? Because that is important to have. You cannot not have that unless okay. I didn't want to. Okay, let's put a screw over it. Otherwise, it's just gonna keep disconnecting and. Okay. Let's just confirm that the device itself is on, because yeah, the device should be on. Charger is on, so let's see PP boss. Where is our? Okay, can check an SML here. No. Is the charger itself working? Don't tell me it wouldn't work with. Okay. Okay. So let's see. Uh, and by the way, you see the CD32s that are used here are completely different. See them? Completely different from the previous ones. Completely. Hmm. Now these are now what are these now? Hmm. SN25 A12. Completely different. Okay, interesting. Okay, let's see. What do we have here? Okay. Um, is this going to be something interesting to find out? So it's don't tell me that it wouldn't work with the old USB-C port. Let's see if that's what is happening here. Let's get a because we confirmed that this the cable the charger itself has power. So let's take its own. uh, wouldn't it be interesting to know that Apple uh, would not allow a Type-C cable to work? Okay, let's see. It'll be very interesting to find out. It'll be very interesting. It was a bit curious. The fact that he put a barcode on it, that was something that, okay, what are they trying to do here? Let's see. That will be very interesting. Very interesting. But I see, I need to really understand if that's the case, the why behind it. Wait, was the multimeter off? Oh, okay. That would make no sense now. Okay, yeah, it wouldn't make sense. I mean, yeah, it was on definitely. Okay, so let's see that. Okay, let's get an M1 board and try that cable on an M1 board. Yeah, because now this is not. You saw that it actually works, yeah? Okay, so let's get a. That would be an interesting. Okay, so let's check this guy here. It's connected. Let's see what we have on PP Box. It's working. Okay. Now let's see if this works here. So it's this an amazing discovery, and it doesn't work either. No, it doesn't work either. By the way, you saw the first time it gave you 1232. That's when you got, because it's going to start from 5 volt and then boost to 20 volt. So when it gives you 12.32, that's when you sit on 5 volt. Then when it boosts, when it goes up to 20 volt, then it goes to 12.0. So the cables are not compatible. It's just a charging cable. Why wouldn't they be compatible? Interesting. Okay, it's an interesting finding. Yeah, we must be. Yeah, we'll have to really take note of that. Uh, yeah, it's just interesting finding. I have no idea why the cable should work on the M1 and not work on the M3s. It's just a charging cable. Okay. Okay. Yeah, but that was alhamdulillah, that was a good finding. I mean, that's something that I never knew about. I didn't know about that part. Okay. And then something else I was also looking for. We were able to easily spot the fuses on the PB bus line, which would on the in the M1s you will find. Let's put this here. So on the M1s you will find that somewhere here, but the M3 board is not that. So that's another thing that in case you, yeah. Okay. Hmm. Okay. Interesting. With this one, so the CD is on the other side, the USB-C port controller, but this one, it's on the side here. Hmm. So, well, I think this is something we obviously have to look to see what it's. And then obviously the 5 volt, the USB-C, the USB line, which is the USB, the 5 volt line, the chip that they use there is obviously different, and that's actually a change. A change. This change is carried from the M2s actually not. So the M2s they have a different regulator for the USB, the 5 volt USB line. Okay. Actually, let me get the M2 board itself. So M2 board. So this is okay, now it makes sense. So this is M1, M2, and then M3. So they had started. So they had moved the CD the CD controller, this port controller. They had moved it from the other side, from the back to the front. So with the M2, they brought it here, which is about the same place. Yeah. So this is an M2 board. The M2 boards still look very similar in terms of the layout. Um, you see this section here that I was talking about. So this change is here. So this chip here, the 5 volt regulator. But this one, this is what they use. This is the same thing as the 13 inches and the MacBook Air. That USB regulate the 5 volt regulator for USB, and then this they changed that in M2. So they use that, and it's still the same thing that they carried over here. The circuitry look exactly the same. Exactly the same. Okay, so this is the M2 board, and then with the M2, they still stick to the standard, the classical CD32 17, and then the M3 they completely change the the charging port controller, and we no longer have that is no longer present. So where are the PP bus? It's on the other side maybe. PP bus voltage. The fuse. Let's see. Do we have it under here? No. Okay. It's going to be interesting to see where that is and what has been done to. Okay, so this is something we still need to look into to understand. Yeah. So, but for now, let's worry about why we're here. So for now, we're here because our trackpad is not working. So interesting changes. Interesting changes. So let's just confirm that we have the PP bus line, which is here. 12.0. Okay, that's fine. So you should capture that. 12.0, that's fine. And then on the other side, we needed the 3 volt on this resistor here. Here we're supposed to get 3 volt, and it's present. And then on the other side, do we have it? Yes, it's present. Okay. So let's move on. That's on 15, and then let's check on the 5-volt line. That's also going to be critical. Let's see, is that present? So we should have that on an inductor. See where it says, so whenever you see L, that stands for, that's an inductor. So it behaves like a fuse basically. So with L, whatever voltage you have on one side, it must be true on the other side. Okay, so let's see that. We're supposed to have 5 volts there. Let's see if we have 5 volt. So that's this guy here, that's the inductor. So let's see, do we have 5 volt? Yes, we have 5 volts. So on the other side, we definitely have 5 volt. Okay, so that is present, and IPD torch. Okay, let's not worry about that for now. Let's see, do we have the 1.8 volt? That should be present. I mean, because the device is fully functional, but you never know. Let's see, do we have the 1.8 volt? 1.8 volts. So that is something that we are going to see. See, where are we going to find that? Okay, so now that's not something that we're able to find. Interesting. Okay, so let's move on to pin 23, 21. Let's see if that is present. That should be 3.2 volt. That should be present, but let's see. Okay, we can check here. 3.2 volt. It's present. Okay, so that's present. That's present. Let's see what else should we look for. And this is present. Okay, 1.8 volt. Okay, so given that the board is so clean, before we continue, we are going to try to revive the device. So first and first, we try to save the device if we're able to put the device into DFU mode, because we don't see anything that stands out on the board, and the voltages, the voltage line seem to be okay. So let's so we are going to revive it, and yeah, just before we do that, let me see. So first thing we're going to try to see is see if the device actually go into DFU mode. Yeah, that'll be interesting to see, and yeah, and then we take it from there. But now it's time for prayers. We go for Salah first, and yeah, and then continue afterwards. Okay, so what we're trying to do is let's see. Okay, so there is something that we are picking up here. We're trying to see if the keyboard trackpad works even while we go to recovery, but it doesn't work. But something else is actually registering to us. The screen is supposed to remain on. The fact that it quickly goes off, that could suggest that the IPD underscore lead open signal, there might be a problem here on this signal, because this signal here is supposed to, when it's high, it's supposed to tell the machine that the lead, the screen itself is what is open, which will activate the trackpad. But if that signal is low, then the machine will assume that the signal is the assembly itself is what is closed. And when the assembly is closed, what happens? The trackpad will be deactivated. So we might actually be having a problem with that signal there, and will have nothing to do with, even because I was thinking of let's reinstall the machine, but that's not going to fix the problem. So what we want to do now is, first of all, find out. We couldn't find out that signal before. Remember, we're trying to measure for 1.8 volt, but we couldn't find out where that signal is supposed to be. But you should have that signal also. Let's see. Okay, so we're supposed to get 1.8 volts. So we may just have to kind of walk blindly, so to say. Then the other side of the board, let's see. On the other side of the board, what about this guy here? IPD underscore lead open. See, this is also the signal that allow you to disable the mic. Dmic underscore disable warning low. So you are 300. So okay. How on the board itself, we know we could not. Yeah, we need to find out. Yeah, we need to find on the board where that signal is. It is important that we get that signal, which is 1.8 volt. Let's see. Okay, let's check for that signal, because I mean, it clearly makes sense that that's what's happening here. The screen doesn't stay on, it goes off. So first thing we want to do is let's disconnect the angle sensor cable. Do you understand? Let's disconnect the angle sensor cable. Let's start from there. So let's disconnect the angle sensor cable. And I mean, obviously the reason why we're doing so is in case the angle sensor cable it's faulty, which would give false information to the machine to assume that the screen is in a particular position where it's not. So let's have that disconnected first and then try again. It is working. It is working, yeah. Yeah, it is okay.
So because of that,
that signal. You see?
Okay, so because the signal was giving the indication that the machine is not lifted yet, that's why
the lead is closed. That's why the keyboard, that's why the trackpad. Remember, that signal, what that signal is supposed to do, is supposed to tell the machine, it's supposed to, when that signal is low, it means that the lead is closed. And when that signal is high, it means that the lead is open. Now, once that signal is low, what will happen is what will happen is the trackpad becomes inactive, because you don't want the trackpad to be active while the lead is closed. So, but then when the lead is it's so now we were only able to pick that up because the screen is supposed to stay on, but the fact that it goes off immediately tells us that there's a problem with the signal. MashaAllah, that's interesting. So the angle sensor gives false reading. So okay, now we know. So alhamdulillah, with that very interesting. Now you just understand how it's important to understand the message, or the message, what it means, what each and every line means. I mean, the lead angle sensor and how it's supposed to behave, because the lead angle sensor, lead open, is supposed to be high, which will give you 1.8 volt. But then when the lead is closed, it should be what? It should be low, which would then disable your trackpad. And remember what I said? I said the keyboard is dependent on the trackpad. So they utilize a single signal to disable the trackpad, which would by itself, which would just disable the keyboard. They didn't have to have like a separate signal to disable the keyboard. So once the trackpad is disabled, automatically the keyboard will also but disabled. So now we see that the problem that we have is what? Is the lead sensor? It's the lead. So it's the lead open signal that is low. Now let's find out why So that is so the IPD lead open 1.8 volts. So that is and that is being pulled down definitely by the angle sensor cable. So what we now want to work around is what is happening on our angle sensor cable. So let's have a look at first of all the connector itself. It doesn't look like anything is funny there. Let's remove the angle sensor cable itself because sometimes you might have a bit of a small like a tiny drop of liquid in that section might actually affect it. So let's take the angle sensor cable out. Mind you, the angle sensor cable is tied to the board, so it's not something we can easily replace. Well, and that's it. See a tiny amount of liquid. You see that? You don't see it. Uh,
Zoom out and come close. Which one?
can't you see corrosion here?
Yes, yes.
Yeah.
Okay.
So that's our problem. So the problem is the angle sensor. In the entire machine, the one place that liquid went to was
That makes sense.
and how would I mean it would just be a bit okay, not a long stretch, but look at the connection from the angle sensor pulling down the lead the link the IPD signal low, thereby disables the trackpad, which then means that trackpad keyboard is not going to work. Okay, so if this was not tied to the board, we just go ahead and replace it. But because it's tied to the board, we have to find a way to work around that. So what I'm going to do is because I'm going to confirm if if that is a capacitor, so we're just going to remove it, and then that. So let's get another angle sensor cable just to see what those are. And so one of the ways you fix this is this, yeah. So the program that's the serialization, it's on the chip itself, correct? Not on the cable. So you can transfer the chip itself onto another cable, and then you're fine. Do you understand? So you can just transfer that onto another cable, and then you're good to go. But then what we want to do is we want to see if these are capacitors, then that will be fine. Then we can just remove that one, the one that seemed not to be in a good state, and we should be fine. But then we can just actually do that now. So let's remove that. Yeah, so that is out of the way. That's out of the way. I hope this is, yeah, that also needs to go. Yeah, that also needs to go. Uh, hmm. Okay, so we need to clean that. Let's get it. Okay, so I think one of the first components that we took out, I think that's a resistor. I'm not so sure, but I'm going to confirm. So let's check another one and see if that's a resistor. Because if that's a resistor, so what will happen is the key the cable itself will not function as a lead sensor cable properly, but then it would not prevent, because we remove the capacitor that's obviously causing trouble, but it's not going to prevent the keyboard and trackpad from working. But then it would just mean that the machine will not detect that there is even a lead sensor present. If because so I just want to, so let's see if one of the component, the one of the ones that we took out, if it's a resistor, which would mean that obviously there is uh, okay, alhamdulillah, it's a capacitor, and imagine even this one. Okay, so it's a capacitor, so that's fine. So let's put that back. So let's hope the chip itself is not affected in any way. If it is affected, it just means that the client would have to use the device without. Okay, yeah, we can transfer the chip itself into another. Okay, so let's see.
So these two devices can do the same thing.
No. Okay, so that's interesting.
Interesting.
Yeah, yeah. So we definitely need to get another. Yeah. So if we do this, yeah. So um so we'll have to get another cable, another sensor cable and transfer. But then now the problem is we are not sure if the chip itself is still fine, because if the chip is not fine, even when you do transfer it, it's still not going to work. Okay, so we'll have to obviously inform the client of what it's what. But as far as the issue itself is concerned about the trackpad, keyboard, and trackpad not working, as you guys can see, that has been resolved, and the device itself is fine. We are just going to work around the lead sensor cable, and yeah. Okay, so the lead sensor was obviously pulling down the signal, and for that, the machine would assume that the screen itself is its lead sensor, that the voltage is low, which would then disable the trackpad, and then thereby keyboard also not working. But with the lead sensor disconnected, the machine is going to work 100%. But the problem is, even when you close the lead, the machine is not able to tell that the lead. You understand? Yeah. So it's just so to put the device to sleep, you have to manually put it to sleep. You understand? And there are more functions that is tied to the lead angle sensor. For example, when you lift the lead for the device to wake, yeah, because it wouldn't know that the lead is now up. Okay, so yeah, thank you guys. I will see you guys in the next one. Okay, so what we decided to do, so we decided to take a 16 inches sensor, angle sensor cable, and then we obviously remove. So this is the one that it's fault. This is the damaged one. So what we did was so to we got a 16 inches cable. It's not exactly the same in terms of length, so we have to do a bit of a tweaking around it. So but basically what we did was, this is the old one that's not working, so we remove the chip, which is the one that is programmed, and then we installed it on a 16 inches angle sensor cable, and so we obviously transferred that onto the machine. So it is installed now. It's working. So this is how it looks. So you see, it's a little shorter. So we need to find a way to work around it. We'll probably not have that installed. Something we just have to find a way, because it's so this is slightly longer. You see, this is slightly longer compared to the 16 inches cable. So we'll have to see what to do and how to do in that regard. Yeah. So, but what we basically did was to transfer, because the serialization is on the chip itself. So we took the chip out and then we put it on the 16 inches lead sensor cable, and that works 100%. It's off. Okay. So I'm just gonna show you guys. So before with that cable, with the cable there, when the machine starts, you really won't see the Apple logo. So until when the device is almost finished loading, will you see it? So, but now we with that out. Uh, so and it also goes to sleep. So if we had to do this, just I'm not sure if you guys can see that. Yeah, now it's gone to sleep. So if I raise it a little bit, now it's back on. So it works. Yeah, but then we just have to find a way to work around the length of the cable. It would have been best if we got a 14 inches cable, but just the one that we got is a 16 inches cable. I'm thinking now, I don't know if we do have a 14 inches. Yeah, the one that we have is like, okay. Yeah, yeah, but that's about it. You guys saw that it works. So yeah, so if you happen to have a problem with a sensor cable, you can transfer the chip itself onto another cable, and it's gonna work 100%. And so it's funny that we started from keyboard and trackpad being disabled, but then alhamdulillah we understood the how it's supposed to work, and then we had to trace it down to the lead, especially because of the hint you gave us. I mean, if we didn't catch the hint, it would have been a bit difficult for us to find that the issue is actually coming from the sleep. And then another thing also was, if we had um, this is not the exact board view, correct? This is a separate board view. However, even if we had tried to measure the lead sensor the 1.8 volt with the logic board out, that voltage would have been present, because at that time the cable is not connected. The cable, obviously, when the cable it's connected, because the cable is faulty, because of the liquid the liquid damage. That's why it assumes that the voltage it's low, which would then disable the trackpad. So even if we were able to measure it, we wouldn't catch it, because we will see that the voltage itself is present, but only becomes a problem when the cable is connected. But alhamdulillah, everything is up and running now, so client can collect. Thank you guys, and then I'll see you guys in the next one.